Hello, everybody. Welcome to another edition of the MakeCode TV Advanced Stream. I'm Richard. Richard on the MakeCode Forum.
I'm Joey at J1 on the MakeCode Forum.
And today we are working on MakeCode TV again. So, if you haven't been joining us for the MakeCode TV project, the idea is that we want to make a game that is gaming, quotation marks, that is mostly just a bunch of shows that you can watch. And the idea is that eventually we're going to do like a mini game jam around this where people can make all of their shows and we'll just have this one MakeCode TV game that be passed around. But for now, what we've been working on is to make all of this happen, we basically implemented a bunch of APIs that we can use for, doing stuff that we would need to make like these cutscenes that these shows are going to consist of, right? So we have move sprite, we have show text, pause, show animation, loop animation for time, show movement animation, and play sound effect currently. And these are all special implementations of these functions. They're different than what the normal arcade ones look like because basically we can swap between channels and they keep going in the background, or at least it seems like that. That's not actually how it's implemented. They're just kind of like written in such a way that we're able to skip to the current point in time when we start playing a channel. Mm. So last time we worked on this, we were doing the sound effect support. So if you hear that sound effect playing, we'll wait for this to restart. There you go. As I switch between these channels, you can hear it turning on and off. And that's because we have the special play sound effect right here, which is basically starting the sound at the right point, as opposed to just starting it from the beginning every time. So today we are going to be working on this and supporting more of the different sounds that you can play in arcade. So to kind of get a feeling for what that is, let me just open up an incognito tab and go to arcade so that I can just open up a blank project. We're going to look at what we got in the music category. Okay, so far we have done this guy, the play sound effect, and we have done the play tone, this guy. I'm going to shut this up. Okay. So those are the two we've implemented so far. We did the play tone in like 30 seconds at the end of stream. The next one, the other ones that we have are we have play melody, we have play song, and we have, oh, I guess that's it. Oh, we have play built-in thing. There we go. All right. So, the play built-in and play melody, I think, are actually the same thing. I previously thought this was the same as this, basically, but it turns out this is actually an array of melodies, which is different than a sound effect because melodies can have things that play at the same time.
Oh.
Some of these have negative hold values set for their steps so that they overlap, which is pretty funny. Negative rest values.
Oh. Okay.
Yeah.
Nice.
But anyway, so what we're going to be doing is we want to, the big one I think that we have left to do is the song, and that's what we're going to be looking at today. So we're going to try and make it so that we can play a song starting and stopping at various points. So I'm just going to go ahead and make a song real quick. This is not going to be anything special. Great. And now we're going to do a second measure using a different instrument. So let's use the burger. Now, let's do the cheers. Great. And just so that we can also test drums, we're going to put one drum track in there too. So I'm just going to choose a drum sound and lay it on out. Great. All right. That's a song. So, whoops. We're going to go ahead and just put this in our on start. Go to JavaScript. We're going to copy this. And we're going to use this in our MakeCode TV test project. So let's go back over to our main.ts, which is where our test things exist. And right now we're doing this play sound effects. So we're going to go ahead and turn that off. And instead, we're going to do custom.play sound effect. We're going to rename this to be just like play music thing. And then we want to grab this create song. We don't want the play part. We just want the create song part. There we go. And now if we play, nothing happens. That's because we haven't actually implemented it with the song yet. So let's do it. We're going to head over to api.ts. We have this play sound effects. Looks like we do that inside of current show. So that's going to be custom.ts. Let's look for play sound effect right here. And here we are checking all of the different types that are being passed in. So little fun fact about the arcade sound blocks is they all have the same type at the end of the day. They're all subtypes of the same type, basically. So everything that has this play until done block around it, these are all what we call playables. So far we've been looking at the sound effect playable and the tone playable. Now we're going to be looking at the song playable. So we're going to collapse this and say, else if sound instance of music.song. Or is it music.sequencer.song? Is this a playable? Let's go back to main.ts and see what create song does. Oh, it just returns a playable. Okay, well, we'll look at the implementation, I guess. I'm guessing it's inside of sequencer. Let's see. No, it won't be inside here, actually. It'll be probably in melody.ts. Create song. Returns new sequencer.song. Okay, so it is indeed a sequencer.song. That's great. So, heading back over here. Collapse. Okay. So we want to find out, we know this is a song now. So we need to first consider how much time has passed into the song that we are playing, right? So when we change to this channel, we could be 5 seconds into the show. We could be 1 second into the show. We could be playing at the very beginning. So we need to figure out how much of that time is eating into our sound playing so that we can start our sound playing at the correct time. So to do that, let's look at one of our other examples here so we kind of see. Let's see. If this.elapsed time plus sound.duration is less than current time. So this.elapsed time is the time that we're currently at. And current time is the time that we are trying to catch up to, basically. So the amount of time that has elapsed is equal to current time minus this.elapsed time. And if that is greater than our duration, we just want to bail out right here, like we're doing here. So let's go ahead and see. We're going to say, let's see. Does this have a dot duration? It does not. We're going to have to calculate it. So const duration equals sound dot beats per minute times sound dot beats per measure times sound dot measures. So this gives us the number of beats total in our song. And then in duration, we also have times sound dot tempo per. There should be a tempo or something like that.
Do we just translate it to beats per minute measure?
Oh, right. Beats per minute is tempo. Whoops. Okay.
Oh, okay.
So we have sound beats per measure times measures, and then we have beats per minute, right? So in order to convert our beats into minutes using our beats per minutes, we need to divide by sound dot beats per minute. Oh, wait. Like, why is my IntelliSense not working? All right, like that. Okay, so this gives us the number of minutes in our duration. We need to convert that into milliseconds. So first we need to multiply this times 60 seconds in a minute times 1,000 milliseconds in a second. So this should now be our duration in milliseconds. So if this dot elapsed time plus duration is less than current time, return, fail out. All right. Otherwise, we're going to have to go ahead and say const elapsed equals current time minus elapsed, or current time minus this dot elapsed time. All right, so this is how far into the song we are. So we now need to play this song, but we need to play this song such that we are starting to only play the node events that are after this elapsed time. So let's talk a little bit about how songs are stored. So I have the formats up here somewhere. Yeah, okay. So a song basically consists of some metadata followed by some tracks. Each track consists of an instrument, which is this bit right here. The instrument is either a drum or it is an instrument. They both have different formats, but we don't really care about that. But, you know, this doesn't affect what we're doing. And then after the instrument, we have what are called node events. So each node event has a start tick and end tick, a number of notes that are in that event, and then each of the notes. All right. So tick is the time thing that we use with our thing here. A tick is equal to like, I think like 1/24th of a beat or something. I don't actually remember. Maybe it's 1/16th of a beat. I'll have to look it up. Okay. But so what we want to do is we want to figure out, we want to basically filter out all of the node events that are that have a start tick before whatever our current tick is in the elapsed time. So let's figure out what our current tick is. We're going to go ahead and have to convert our elapsed into tick. I think we must have sequencer, let's see, music.sequencer dot somewhere I must have code that converts millis to ticks and ticks to millis. This has to exist.
Probably.
Let's look. There it is. See, it's in the sequencer class, but I can just go ahead and copy this. So let's go ahead and copy this. There we go. So this is going to take in ticks, and it's also going to take in BPM, not BOM, and ticks per beat, like that. Then we can go ahead and change this to BPM and change this to ticks per beat, like that. And then this gives us our milliseconds. All right. So we're going to go ahead up to our elapsed right here, and we're going to say const start tick equals we were going to do a tick to millisecond of 1 tick, and we're going to do sound.beats per minute and sound.ticks per beat. And we are going to, now we have the amount of milliseconds in 1 tick. So in order to figure out how many ticks have elapsed, that's going to be equal to this divided by our ticks to milliseconds. So elapsed divided by is going to return some floating point number. We want to convert it into an integer. So I'm just going to do math.lore like that. And this will give us whatever our start tick is. Okay, so we now need to loop over all of the tracks in our song. And we need to filter out the note events that are before that. And that's easier said than done. So we're basically going to have to create a new buffer, which is going to be like a partial song.
Yeah.
So might as well just get started. We're going to go ahead and do for const track of sound dot tracks. We are going to, for each of these, basically do 2 passes. So first we're going to do a pass to figure out how many note events we're cutting out and how many bytes that's going to be that we're cutting out. And then we're going to do a second one where we write the thing to a new buffer, which is going to be our track buffer. Then we're going to assemble these all together again into our song. So let's go ahead and say, oh, whoops. We're going to do let byte length equal 0. So we can go ahead and look at our track or our byte thing right now. So we always have, looks like the first 4 bytes are just like metadata. Then we have the length of our instrument. So we're going to go ahead and say equal 4 plus I'm going to guess, yeah, that instrument's byte length is going to be 2 bytes. So we're going to do 4 plus track dot instrument byte length. Cool. I was like, I hope I made getters for all of this stuff, and I did indeed. Okay, so that's going to give us this offset. And then our notes byte length, that's going to be 2 more. So we're going to add 2 to that. And this now gives us the offset where our notes start. So we're going to do track dot, I think there's like a get note at or something. Okay, we have this advanced note event. So let me look at what that does. We're going to head on over here. Control F for advance note event. All right, well, this has to be implemented somewhere. Where are the types for all this stuff? Oh, it must be inside of an instrument. All right, Control F for advance note event. Okay, so this is going to have, okay, so we have basically a note event thing, which is equal to this start. Oh, hey, this is nifty. So instead of doing all of that math I was doing before, I can just do this. So track.note event start plus 2. And then we want this to be length. So we need to do minus track.offset because the offset is where this track starts in the overall buffer. All right. Now what we're going to do is we're going to say while track dot current note event dot end tick or start tick is less than start tick, where you're going to do track dot advanced note event. All right. What does the advanced note event give us when we get to the end, I wonder? Oh, it goes back to the beginning. Okay, so that is no good. We don't want that to happen. We need to detect when we loop back around. So, because there's a chance that all notes that are in this track are before this note event, in which case we just want to remove this track entirely, basically. I don't think we're actually going to do that, but yeah.
Gotcha. So that would be like, you have the track that only plays at the beginning, and then there's another track that plays afterwards.
Exactly. I mean, that's how our current one's set up. So we have one instrument that plays in the first measure, one instrument that plays in the second measure, and then one that plays in all measures. So if we start in the second measure, that first track is going to have no notes, and this will run forever because we're just going to keep advancing our note event until start tick is less than start tick, which will always will be, because it'll just loop back around at the beginning. So I think what we're going to do is if track.currentNoteEvent.startTick is greater than or equal to start tick, then we're going to do something else. We're going to do while track.current note event.start tick is less than start tick, we're going to call this advance, and then we're going to say if track.current note event.start tick equals track.note event start plus 2. Sorry, not start tick. Dot offset equals track.note event start plus 2. Then we are going to break cool. So this will detect if we are looping forever, which is good. Right here, so if the start tick is greater than or equal to start tick, then we just want to preserve the instrument exactly as is. So in this case, we want to do byte length equals track.note event start plus track dot, or I guess we can just do byte length plus equals track dot note event byte length, like that. Okay, so this is, we don't cut anything in this case. And then right here, we're going to be like, let no notes equal false. And then in here, we're going to say no notes equals true. And then we're going to say if no notes, then we are going to say byte length. We don't do anything to byte length. So the byte length is correct because we are going to have no notes after this. Otherwise, we are going to do our byte length is equal to, we need to subtract the length from our current note event. So we need to do track.current note event.start tick, not .start tick, .offset minus track.note event start plus 2, like that. And this is going to be byte length plus equals that. All right. So if everything in the track is after the start trick, then we don't do anything. Otherwise, we want to advance until either we loop or we hit something that is above the start tick. And if it is above the start tick, then we add everything. We add the oh wait, this is adding the offset that we are actually deleting. So this should actually be track.note event byte length minus this. All right. Cool. Okay. So this will give us our byte length. And we need that byte length so that we can now do const buffer equals control.create buffer of byte length. That. All right. So we need to write all of our new track inside of this buffer. So the first thing we want to write is all of this stuff before the notes, right? So we're just going to go ahead and copy this all verbatim. This is not going to change even if we trim our thing. So we're going to go ahead and do buffer.write, and then the destination offset is going to be 0, and the source buffer is going to be track. Wait a second. Oh yeah, so we want to do track.buff.slice track.offset to track.note event start.
Okay.
All right, I think that's right. So let's go ahead and make sure we have the correct meaning of note event start. So this is equal to this.offset plus this.instrument byte length plus 4. So if we look at our definition, that's going to be the 4 are these first 4 and then the instrument byte length. Right. So that puts us at the notes byte length. So indeed, that's what we want to copy over. We want to copy over everything. And then we want to do minus track.offset. We want to copy over everything except for the notes byte length and all of this stuff. So let's go ahead and do prefix equals and put this in here. And we're going to put a prefix right there. All right. So we now need to write our note byte length. So that is going to be equal to, we want to do buffer.write or dot set number format dot uint16le, and we want this to be equal to the number of bytes in our note events. So that is going to be equal to our byte length minus prefix dot length minus 2. So that 2 is for the 2 bytes that we're currently writing. And the value we want to write, oh yeah, and we want to write this at track.note event start minus track.offset. There we go. Okay. All right, so we have now written our preamble and we have written the current byte total of our thing. So at this point, we just need to write in all of our note events now. So we're going to go ahead and say while track dot okay, let's just do let written bytes equal 0, and we're going to do const note bytes 2 writes, just 2 write, not 2 writes, as much as I want it to be. It's going to be equal to this, that right there. And we're going to say while written bytes is less than note bytes to write, then our current note event should be at the correct start, right? Because we advanced it until it was, above. So we're just going to go ahead and write our current note event to our buffer. So we're going to do const note start equals track.note event start minus track.offset plus 2. Okay. So we're going to go ahead and write this in by doing track.current note event dot we're going to do buffer dot write. The offset is going to be equal to note start plus written bytes, and the source is going to be track.current note event dot buff dot slice track.current note event dot start tick, and then track.current note event dot byte length. There we go. And then written bytes plus equals track.current note event dot byte length, and then track.advanced note event. All right. Okay, so this should write them all in. Now, this isn't going to be quite right because what we're doing here is we are copying over our notes verbatim, when actually what we need to do is we need to shift them all over by our start tick. All right.
Mm-hmm.
So let's go ahead and say const to write equals, and then grab this slice we're doing.
Just to make sure I'm on the same page, basically what would happen if you had run this one would be that it would be the same track, just with the first X nodes elided, and you just have a blank space for that first 5 seconds.
Correct.
Or whatever.
Yes.
Okay.
So we're going to go ahead and look at our note event format. So our note event format is the start tick is the first 2 bytes and the end tick is the second 2 bytes. So those are the 2 we want to change. So we want to do 2 write dot set number. The number format is going to be uint16le. The offset is 0, and the value is 2 write dot. Well, actually, I can just do track dot current note event dot start tick minus start tick. That's duplicate that. Now we're going to start at 2, and this is going to be end tick minus start tick. And then we write to write. We add our written bytes, we advance. There we go. Now, once this loop is done, we now have a buffer that contains this track. So we're going to go ahead and do const track buffers, which is going to be a buffer array equals that, and we're going to do track buffers dot push buffer. Great. All right. So we have all of our track buffers now. We now need to write out our song. So let's look at our song encoding. So we have a version, beats per minute, beats per measure, ticks per beat, measures, number of tracks, and then all of the tracks. So none of this changes. Right? The only thing that changes here is the number of tracks. Is the length of each of the tracks. So to do this, all we need to do is do here. We should also do let total track length equal 0. And then in here, we're going to do total track length plus equals buffer dot length. All right, now down here, we're going to go ahead and do const new song equals control dot create buffer. I don't know why create buffer doesn't show up in IntelliSense. Control dot create buffer, and this is going to be equal to our total track length plus 7. 7 is our prefix. Then we're going to do new song dot write. And it's going to be sound.buff. Destination offset is going to be 0. And this is going to be sound.buff.slice 0 and 7. So it's going to write the first 7 bytes to our song. And then we want to do let current index equal 7. And for const track buffer of track buffers, we are going to do new song dot write at the current index our track buffer, and then we're going to do current index plus equals track buffer dot length. We did it. So now, once this completes, we should now have new song, which is a new song that starts at the start tick we have been given. So we're actually going to go ahead and play this song now. So we're going to do music.play new music.sequencer.song of new song. And we're going to do music.playback mode in background. And finally, we're going to actually run this as a task. So it's going to be this .run task, just like we did before. And this is going to be duration. And this should do all the pausing and stuff we need. All right. Okay, we immediately failed. That's great. I was not expecting. We wrote so much code just now. I was like, there is no way this is going to work correctly first try.
Yeah. It looks like create buffer doesn't show up because it's deprecated in favor of pins.createBuffer.
Oh, really? Weird. All right. I never use pins.createBuffer. I always use control.
Yeah.
All right. So
52, we got 1. Nice.
I already tell this is going to be a pain to debug. All right, let's just go into debug mode. Add back over to custom.ts. Go to play sound effect. And we're just going to go ahead and step right through this guy. So go ahead and continue. Here we go. We're here. Going to step over. Our duration is 4 seconds. I believe it. Step over again. Looking good. Okay. Our start tick. Our elapsed time is equal to not a number.
Nice.
All right.
Okay.
So this is probably where we're going wrong here. So our current time is equal to not a number. Our current time is being passed in as this.showTime. And our elapsed time is 0. Okay, so our current time is returning not a number, which is causing all of this to break, I'm guessing. Mm-hmm. Because now start tick is going to end up being not a number. And that means we're going to be writing not a number into these buffers. I actually have no idea what that'll do.
I mean, it's a bit. Yeah, I have no idea.
Yeah. So, all right, we need to figure out why we're returning not a number for our current time.
Current time is already used in like the animations, right? So that should, or was that? No, it should be.
Okay, we're gonna look at line 122. I think I might know what's happening here. Custom TS line 122 is this constructor. Okay, so the reason we're currently failing is because this is our time calculating stage.
Yeah.
So we forgot to do something for that. So let's go back to our, let's go out of debug mode. We're going to go down to our play sound effect. And we are not doing this calculating time bit. Actually, we're not doing for all of them, but I guess for the other ones, it didn't actually affect it. In here, it actually matters. So let's see. We calculate the duration right here. So for the sound effects, we loop over the sound effect, we figure out what the duration is, and we check out the sound effect time plus duration. If any point we get past the current time, then we actually play it. So we need to know what the total duration is. Oh, and we can just get that from sound.duration. Okay, that's great. So we can go ahead and say, if this dot calculating time, this dot elapsed time plus equals sound dot duration, and return like that. All right, down to the next one. Let's see, should this be happening before we do the, yeah, I think this should be happening before we do the bailing out. So if this dot calculating time, we're going to do this dot elapsed time plus equals sound dot duration. Great. And now right here, we're just going to go ahead and say, if this dot calculating time, and then just do plus duration.
Hey there,
All
Sean.
right.
I didn't post an early message today, so I don't know if you can see him.
All right, well, it actually played a sound.
Nice.
So that's kind of cool. All right, so we need to figure out all of the values that we're kind of calculating here. So we could debug again, but I'm just going to print them out because I have a feeling we're going to want to be referencing them a few times. So let's go back over here. We're going to go ahead and collapse. Right here, we're going to say console.log play song, and then we're going to do elapsed and start tick like that. And let's just see what we get for now. So we did play song 0, 0. So in this case, it shouldn't have done anything to the song. So back down to where we were.
I'm just gonna
what?
That one out. I don't think that's the same song. It's about the level of contributions I can make to this. So I'm just putting it out there.
All right. This isn't even music stuff. You can help me with this coding.
Got the pipeline we got.
Okay. So if track.currentNodeEvent.startTick is greater than or equal to start tick, then, all right, we'll debug. I didn't want it because it's going to make me switch files again, but continue. We're going to go ahead and go on down to our play sound effect to right here. And we're going to put our breakpoint right here. There we go. We hit it immediately. So this time we have, let's go ahead and just step. We have our start tick is equal to 0. We have our elapsed is equal to 33. Okay, so that seems about right. Our elapsed is only 33 milliseconds, so that's not even enough to do a single tick. So we are now going to just keep stepping. So we're going to see where we go in this if statement. There we go. This is correct, right? So our track.currentNodeEvent.startTick. I don't know if we're actually going to be able to see that because it's a getter. Yeah, we can't actually see that because it's a getter. But we're just in the case where we know that we want to do all of our bytes. So we're just going to add our total node event byte length. So now when we step over here, we have a new buffer, which we're going to be creating with the byte length. Good. We have our prefix, which is got actual data in it, which looks good. We can't actually see what the length of it is. I guess buffers just print out in hex. That's interesting.
I guess it makes.
Yeah. All right, so we're going to go ahead and step over. All right, so our track.currentNode event, we're going to be doing this slice. So let's step over and make sure that this to right actually has stuff in there. So, okay, to right has 0078000040802. I can't read hexadecimal that easily. So, but sure, seems good enough. So we're writing the start tick minus start tick. Start tick here should be 0. Looking good. So this should just be writing the exact same number for these first two. So let's go ahead and see what our note start is equal to 34. And we're going to do step. And we're now going to go ahead and check that index starting at 34. So this is going to be a pain, but we're going to do 1, 2, 3, 4, 5, 6, 7, 8. Whatever. I'm not going to count all of that out. Okay, so it starts out with 0, 0, 0, 0, 0, 0, 4, 0, 0, 0, 8, 0, 2. So we can see it right there. That's it right there. Which seems good enough. So this should be starting after the, let's see, that's 5 zeros. So 1, 2, 3, 4, 5. So we can see we have 2 zeros here and then 43. So this 43 right here is going to be the node event byte length combined with the 0, 0. These are the higher significance bits and these are the lower significant bits. So 43 in hex is equal to 4 times 16 plus 3. So that's 67 bytes. So we have 67 bytes after here that we're writing in, and this is the first of the node events that we're writing. Okay, so we're just going to go ahead and set a breakpoint here and then continue until we've written all of these out. Here we go. We're going to go ahead and look at our buffer now, and it should be full. Whoa, okay, wait, why is it so? Oh, I accidentally continued until all the way through the end. Whoops, that's my bad. I meant to continue to here. So let's actually do that. We're gonna. Okay, so right here. Now we've written all of the bytes. If you look at our buffer, it should be full Yeah, it looks good. So we have a bunch of, things getting written in here, which, I don't know what it should look like exactly, but it seems good enough to me. Cool. All right. So at the end here, we should have our total track length, which is equal to 82. And we are adding that. Okay, so that seems sort of wrong, I have to say. 82 seems sort of wrong.
Too long or
too short, frankly.
So it would be 1, 2, 3, 4. Okay, yeah, that would be too short.
I guess what we can do here is let's just continue until we hit this thing right here. We're going to go to our total track length, and we're going to see if the total track length is equal to the length of our original buffer.
Gotcha.
So we're going to go down here. We can't actually compare the two because we can't actually see what the length is. But if we go into sound and then click on the buffer, so this is how big that buffer is. All right, so this is 1, 2, 3, 4, 5, 6, 7.
I've got it. I got my hand on the screen with the link.
So we're gonna go ahead and step over now and see, is our new song the same length? Oh gosh.
Oh, it's a new song 0. That would make it easier.
Well, it's all, we haven't written it yet, so it's all 0 right now.
Yeah. Oh, but it's not gonna. We're not gonna be able to see it.
Yeah. No. Okay. We're gonna do this a little bit more
rigorously.
Yeah, we're gonna go out and actually copy the values. Right click. Is there a copy? I want to copy the inner HTML. All right, we're just going to copy styles because that has the entire value in it, apparently. Let me open up VS Code.
We should add that you can click on those to copy the value sometime.
Would be nice. All right, I'm just gonna, whoa, didn't mean to copy all of that.
It was all the styles, okay.
Yeah. Okay, I want to copy, all right, we'll just copy the element. And I'll just trim around it. So go ahead and paste that in there. Astronomer says, I have a question unrelated to MakeCode TV. Why are some block catalogs hidden in the files? Like power.ts. I'm not exactly sure what you mean by block catalog. Be nice if we could be more specific there. All right, sound buff. There we go. We're going to go ahead and look at this one now. Right there. We're going to copy this. Wait, that was much easier to copy than I thought it would be. We're going to paste, and oh, they are indeed the same length. That's cool. We're going to step to where we actually write the thing now. And remember, we should be getting the same buffer out of this. So we're going to go ahead and do continue. Now we're going to grab our new song buffer. Paste that in there, and oh, we can see already it's quite a bit different.
That does look not exactly the same.
Yeah.
Like the areas of blocks like sprites and controller. Where are you seeing this power.ts? Because I think I vaguely remember that maybe being in common packages. I don't think that there is an arcade power.ts.
Yeah, I have no idea what
I think that might be like a microbit package or something like that.
We do have some power stuff in arcade that is for like sleeping the console and stuff.
Yeah.
But there's no reason to have blocks for that, which is why there are no blocks for that. Yeah, okay. So it looks like as soon as we start writing the tracks, we are kind of running out here. Let me also see what the length of this is. So this is 1,598. So that means the number of bytes in here is 1,598 divided by 2, which is 799 bytes. And let's go ahead and look at what our total byte length is, or our total track length, I guess. Our total track length is equal to 792. So 792 plus 7 is 799. Okay, so we did actually calculate all of that correctly. It just seems like the stuff that we're actually writing to the buffer is wrong. All right, so here's what we're going to do. We're going to go ahead and kill off this debug, and we're just going to refactor our code a bit, and hopefully by rewriting it, we will shake loose whatever the problem is. So we're going to go ahead and say const current track equals track.buffer.slice from track.offset to track.byte length. All right. So we have now our current track in a buffer that starts at index 0, and I'm hoping this is going to help us get rid of some of the confusion. All right. So we're going to take this current track, and the first thing we're going to do is we are going to, when we write this prefix, we are going to be doing the current track dot slice. We're going to start from 0, and then this is going to be track dot node event start minus track dot offset. Wait a second here. So the thing that we're doing right here is this track node event start. Yeah, this works. So the prefix is equal to the node event start minus the offset. That's what the length should be. Looking good. All right, so we write that. Go ahead and write that in. Now in here we have, let's see, set number. So we're doing track.node event start minus track.offset. This is setting the amount of bytes that we have to write. So instead, what we're going to be doing here is, no, I guess this still works. So we want the node event start minus whatever the offset is. This gives us the offset for the node event start. I think node event start, though, I think we might have, yeah, no, this is fine. And then note bytes to write is right here. So note bytes to write is equal to byte length minus prefix dot length minus 2. That seems right. Okay, so let's go ahead and debug again. We're going to run this. We're going to go to our custom.ts. And we're going to see if we can figure out where we're going wrong here. We're also out of time, but hopefully we can just figure this out right now. So we're going to go to when we have written our buffer. So right here, I want to just see where the problem starts coming in. So we write our buffer right here, and then we have our track buffers.push buffer right there. Okay, so we're going to go ahead and just restart so that we hit this. There we go. We now have our buffer that we were writing, which is buffer. So I'm going to go ahead and grab this guy, grab the value of this guy. So once again, we're just going to inspect. Woof woof says, oof, looks like I missed it. Yeah, a little late today. All right. We're going to kill this, paste this in here. Wait, delete all of this, paste it. There we go. Okay, so these are the bytes for one track that we've got right here. These are the bytes that we came up with. So these are the ones that we're writing. And then the ones for the original track are going to be equal to this current track buffer. So this current track buffer is right here. We're going to go ahead and copy that.
So since this one's all the zeros at the front, does that, would that mean that this is the latter half track? Yeah.
What's up, Joey?
I was figuring out buffer this was. Okay.
Yeah. So it looks like this is where we start going wrong, or rather this is. So if I'm not mistaken, this 43 right here should be the number of bytes that we are writing for the node events. All right. So everything after this is node events. So for each of our node events, we have this little 0 prefix, then we have 8, and we can see it's all wrong for everything down here. Now, in our thing up here, we also have a bunch of zeros at the end, which we do not have in the correct one. So I wonder if perhaps what we're doing is we are overwriting the previous one. Do you get what I'm saying? Like a little bit?
Yes.
Though that doesn't completely make sense, I guess.
I don't see it where the like I see where it's switching over. I don't see how we're getting the values that swapped there. It feels like we're writing double the values.
It's weird because we should just be copying it directly, you know?
Mm-hmm.
We must be putting in the wrong offset or something.
Could we,
so we should be...
Could we put in just like a dumb if statement? Because if we look at that buffer, we can kind of tell where it's going to start to go wrong, so we can inspect it at that point, right?
So
there's a bunch of zeros before the first note that
yeah, okay.
The first note is the one that's wrong. Yeah.
So right here, we have, this is after our buffer has finished writing. So we want to do it right here. Okay. So we have our note start right there. We have already written the number of note bytes to write. So our buffer right here goes to 00040 is what we're at right now. Oh, and then over to 43 right there. Okay, yeah. So that 43 is the end of what we've written. And if we go ahead and look at what our current track is over here, where is it? These are not alphabetized. There we go, current track. We can see it does indeed go up to that 43. So that is, I believe, the cutoff for when we start writing node events. And the 43 here is the least significant bits. So it actually starts 2 bytes after this, or 1 byte after this, right? Which is this right here. Mm-hmm. So the first node event we write is 00000040, whatever.
Yeah.
So if we look at, I guess what we need to do now is get rid of this. Just to make our debugging easier, we need to go ahead and say, oh, we already do actually have this 2 right.
Okay.
Oh, okay, here it is. Start tick. This should be offset.
Wait. Oh, okay. Yep.
All right, great. See how much time it takes to debug a stupid... All right, that seems to be working. Which is nice. Okay, it didn't start playing this time. Or it did, but after like a long delay.
Mm.
Okay, weird. I don't know what this long delay is that we have at the beginning of our thing now. Well, it worked correctly this time. Now it's working fine. All right. Well, okay. we got some bugs to work out, but I think we got it mostly working. So that's great. We're going to be working on this again on Wednesday. So hopefully there will be less debugging now that we figured out that one issue, and less comparing binary.
Yeah.
So tune in. It's going to be fun. I'm also probably going to have a lot of music related stuff to demo on Friday. So look forward to that as well. And anyway, I am Richard at Richard on the MakeCode Forum. Thanks for watching.
I'm Joe at J1 on the MakeCode Forum. Which remaining things were we having to implement for the sound on Wednesday? It was the
melodies.
Melodies. Okay.
Yeah. So once we've done
simpler.
Yeah, it's these two blocks, the play melody and the play sound. And I think this melody maps to the same melody that this does. So problem is, I think we're probably going to have to duplicate a bunch of code to do this, but it'll be okay.
Yeah, it's fine. Maybe we can sneak in a quick beta release, which will let us copy up buffers.
No, I don't know. It's going to be a pain anyway. All right.
Yeah.
Thanks for watching, everybody. See you later.
Bye.
Bye.